Hi, my name is Nur Syamil binti Mak Yusof and I will start with the introduction. Malaysia has a heavy rainfall almost every year with an average of 2000 until 2500 mm. The monsoon seasons, which typically last from April to September and from October to March, cause these rainstorms to grow considerably stronger. Several areas of the country, particularly Selangor, will experience flooding. The increasing rainfall is typically too great for the rivers and current drainage system to handle, which result in water overflowing the bank. In this project, there are two objectives. First, to simulate the water flow level of Sungai Langat using Hec-Ras software, and second is to propose the suitable modification for Sungai Langat to avoid overflow.
Hello and Assalamualaikum. My name is Wan Nabiha Kamila, Baker Barometry number AF190070, and I will be presenting the methodology part. Okay, so first let's take a look to our study area, which we have chosen the Sungai Langat, Selangor. So generally, Sungai Langat, Selangor is 78 km long with a catchment of 2,350 km square. So Sungai Langat always exposed to flood event, and there's a lot of various heavy manufacturing industry area, residential house, agricultural activity along the Sungai Langat. So flood mapping created to provide information and facilitate rescue to relieve effort during flood event. Alright, let's proceed to channel purpose. As you can see from this figure, in order to view and study our proposed channel, we use the Google Earth Pro software. And for this analysis, we have evaluated a total of 7 cross-sections, where the total distance will be 3000 meter, with the length of each cross-section is 500 meter, starting from station 1 and moving upstream to station 7. Alright, next for the flood plan analysis with the Hec-Ras software. So now I will elaborate the simulation procedure using the Hec-Ras. Okay, so first we open Hec-Ras software and create a new project and draw the Sungai Langat river, and then we input all geometry data including cross-section, downstream ridge length, mending coefficient, left and right base texture for each channel with different distance from origin. Okay, next we perform the steady flow, and then we run the steady flow analysis, and the last step is the output will be displayed like this after it has successfully run without encountering any errors. So that's all from me. Thank you.
The tree in which we covered the analysis of data in discussion. So in this chapter, there will be 3 subchapters in which we have manipulate the variables of Q, in which for 3.1 will be the simulation of steady flow analysis. The value of Q is set to 85.6 meter cube per second, and then 3.2 is the modification of steady flow analysis simulation at maximum capacity, in which the value of Q will be the 570 meter cube per second, and then the third one, 3.3, modification of steady flow analysis simulation with over maximum capacity. The value of Q is capped at 600 meter cube per second. So for 3.1, the behavior of Sungai Langat can be predicted by using Hec-Ras model and series of reports. From this, the result provide key output variables, which is the firstly is the discharge flow value, the flow area, and also the river specifications parameters. For this, we have set 7 stations plotted along the river, and the Q value is set to 85.6 meter cube was taken for each stations. And based on analysis, Sungai Langat loading capacity are still able to accommodate all stimulated designs value, and in which it is being predicted in this profile output table of proposed channel. So for the Q and then minimum channel, the elevation, critical, everything is being provided in this profile output table.
Good day, my name is Felix Santana Petrus Philip. So I'm going to talk about the modification of steady flow analysis simulations at the new Q, which is 570 meter cube per second. So as you can see here, this is the cross-section data that illustrates the river station at 0 meter with the new value of Q. Next, this is the cross-section data that illustrates the river station at 500 meter with the new value of Q. Moving on to the next cross-section data, which is illustrate the river station at 1000 meter with the new value of Q. This is the 4th cross-section data that illustrate our river station at 1500 meter with the new value of Q. that this is the cross-section data that illustrate the river station at 2000 meter with the new value of Q. So as you can see here, this is our cross-section data that illustrate the river station at 2500 meter with the new value of Q. Last but not least, this is the last cross-section data that illustrate the river station at 2000 meter with the new value of Q. So what we can conclude from those cross-section data is, for the first one, it shows that at 3000 meter river station point, the water level has reached up to 15 meter height, which is satisfactory from the utmost point of 15 meter elevation height. Thus, the chances of having flood in the area of Sungai Langat is still in low risk if the steady flow with the maximum capacity of Q 570 meter cube per second could be maintained from time to time. It also can be noticed that the water level at Sungai Langat is in the conditional state of its peak in bearing the maximum water level before the possibility of having overflowing river. So that's all from me. Thank you.
Hello and Assalamualaikum. My name is Rozayani, and for my part, I will be presenting on modification of steady flow analysis simulation for over maximum capacity, which is Q equals to 600 meter cube per second. So as mentioned, the maximum capacity of Sungai Langat limit should only be reached by Q equals to 570. However, by having a situation where Q has over the limit, it is assured that flood and overflowing will happen. On top of that, compared to previous simulation of maximum capacity for Sungai Langat, the arising water level has reached up to 15.1 meter, while the limit should only be 14 meter high. So as can be seen here, these are the cross-section data illustrates the river station with Q value equals to 600, where this is an example of river station at 1500, 2000 meter, and until it reached up to 3000 meter. And lastly, the overall output result for proposed channel which surpassed the maximum capacity, and to avoid the undesirable occurrence, the volumetric flow rate should not exceed the stated limitation. On the other hand, the river slope should have more gentler inclined slope as it increases the flow area and able to act in a vertical occurrence. That's all from me.